My name is Ryan Gregg. I'm a product manager on the Serverless team and on Knative.
Mark Chmarny. I'm one of the technical program managers looking after Serverless at Google.
Before we get started, I just wanted to take a quick audience poll and say, how many of you use Kubernetes? Cool.
You're in the right session.
What?
You're in the right session.
Yeah, that's right. How many of you are developers on Kubernetes? You're writing apps that run on the platform. Okay. How many of you are operators of Kubernetes? You make sure that other people's apps work. Good.
I see a lot of people who raise their hands both occasions.
That's right, yeah. And then if you didn't raise your hand, what are you doing here? No? All right.
All right, so the session is called Kubernetes or Run Serverless Everywhere. I want to break down we will get to the everywhere portion in a minute, but I want to break down the serverless first apart a little and kind of tease it into the conversation after that. To a large degree today, if you talk to people in the community, serverless equals function. You push some code to a cloud and you have it execute over there. But is it really the case? Is serverless only a function as a service offering? That's kind of the question I'm posing to you. So developers, I think to a large degree, the properties of serverless are pretty commonly understood today. And they break down into two separate things. First of all is the operational model, how you run serverless, maybe not develop, but run the serverless. So first of all, you shouldn't have to worry about the servers underneath. It's right in a name. I don't think we can argue about that. The other thing is that it also comes with a certain level of trust, which means when you push your code and executes on a framework that you do not provide, that there is a certain amount of security that's integrated and managed for you. So you don't have to worry about that either. And that you paying only for what when you use that service, when you're actually doing something. More importantly, you do not pay when it's not doing something, right? So when a code just sleeps there and not doing anything, you shouldn't pay for that. So that's the operational model. In the programming model, the developer experience on a serverless platform, we ideally have a service-based development model. So you call APIs. You don't run a bunch of scripts that just, you have to move over and define a bunch of environment variables and all that. And it's event-driven. So you don't write all kinds of code to keep watching. Is the file there yet? Is the file there yet? Is the file there yet? But you actually are subscribing to an event. Tell me when the file arrives and I will fire something. These five are pretty well understood, and most people agree with the same thing over and with those properties of serverless. What I would like to add in here is one more, and that's portability. And I think because you're in a session which title Run Serverless Everywhere, I assume portability is important to you. So portability is more than just being able to take that code that you have built in one platform and able to take it somewhere else and run it on another platform. It's about being able to expect the same developer experience on each one of those platforms. So for example, the Cloud Run service that we announced this week, Cloud Run that is managed and hosted, and Cloud Run that runs on GKE, the same developer experience. So not only being able to move this from one platform, one operator to another, but being able to depend and being able to benefit from the innovation that cloud service providers offers for you. And not having to, the other important aspect of being portability is that you don't have to make a choice day one, when you start thinking, you have this great idea, and you're going to write some code. You shouldn't have to, at that point, say, I'm going to write code that's going to run on a platform X. You should be able to use your idiomatic developer experience. Idiomatic is just a fancy word for natural. It just comes, you don't have to learn any special. The way you develop in Go or Node.js applications right now is the very same way you should be able to develop those applications for serverless. Now, that means also that you should be able to preserve the investment. There are technologies nowadays coming and going every month. And if we ask you to learn yet another framework or yet another set of APIs that may be here tomorrow or not, it's not it doesn't preserve your skills. So you have to continuously learn new skills. With serverless, we're hoping that the experience is so portable that not only the technology and the tooling is portable to another environment, but you actually are able to take your skills and be very productive in another platform because the set of experiences that are exposed to you as a developer are one and the same. So I think at this point, I think we would agree that serverless is bigger than just a function. And I would pose at this point that serverless is also bigger than just compute. If you look today at GCP, at the portfolio of serverless offerings on Google, they span from everything from data and analytics products, machine learning and some kind of AI. Our message queuing is serverless. Even the developer experience, so DevOps tooling is serverless. And you might have seen some of that yesterday during the keynote in developer evening session. So bigger than function, bigger than compute, and able to benefit and kind of comprise them with the same developer experience. All right, I want to ask Ryan now to talk about serverless on Kubernetes.
Thanks, Mark. So what about serverless on Kubernetes? That's an interesting idea. First of all, I think everybody in here, because you're Kubernetes operators or developers, except for those of you who I don't know why are here, understand that Kubernetes is really the de facto platform now for running containers on the cloud, on-prem, anywhere that you want to take those workloads. In fact, there's a giant ecosystem with pretty much every cloud provider, major and minor, participating in running a certified Kubernetes instance. Kubernetes has really taken off over the last 4 years and become a de facto way of doing container orchestration. But what does it really look like when you break it down? Kubernetes for operators, it's done a lot to improve the operator experience for running containers. It's taking care of the needs of scheduling and lifecycle, discovery, load balancing, storage, all the things that you had to worry about and manage and operate on your own before. Kubernetes has done a lot to make that easier, more straightforward, and simpler. Did I just say simple in Kubernetes? Anyway, there's a broad number of features that pull into this, all these great things that you can do. And the really great thing that Kubernetes has done is it's created this even platform across all the different environments where you can run. So the learnings and the knowledge that you adopt as part of using Kubernetes apply whether you're running Kubernetes on Google, Kubernetes on-prem, or somewhere else in another cloud. For the developer, though, developers really just want to write code. So that's the core business value that they provide. But if you're building on top of Kubernetes, there's all of these other things that you have to do. You have to containerize your application. You have to figure out how to upload that application into a container registry. You have to actually deploy the service, create the deployment, and all the underlying objects inside the Kubernetes API. You then have to figure out how to expose that to the internet or to your service mesh or to whatever the ingress gateway that you're going to be using is. You have to set up logging and monitoring and deal with all of these aspects. And then you have to figure out how to properly scale your workload. You might have an I/O-bound workload where you could put a lot of concurrency into it, or you might have a CPU-bound workload where you need to do more horizontal scaling. There's a lot there, and a lot more of it than just writing code. So earlier this week, we introduced Cloud Run, which is this concept of bringing serverless to containers and trying to remove a bunch of the details of the infrastructure and what underlies what it takes to run one of these containers in the cloud. And Cloud Run is available as a fully hosted service. So you don't have the Kubernetes aspect. You don't have to worry about any of the details of what cluster it's running in, how it's horizontally scaled. You just provide the container into Google Cloud, and we go run it for you, giving you a URL that you can access, giving you SSL, all of the benefits of running on a serverless platform, which is great. But all of you aren't running on a serverless platform. You're running on Kubernetes. So we didn't want to leave you out. So we also brought Cloud Run on GKE, which is the same great Cloud Run experience for the developer, but running on top of Kubernetes engine. So it gives you the flexibility to continue the Kubernetes investment that you've already made, but to get all of the benefits of serverless for your developers. Things like automatic scale, easy deployment, network programming, and automatic participation in the service mesh are all features provided by Cloud Run on GKE. It also integrates with all of the Kubernetes features. So using policy management, is that what it's called? I can never remember the name of that feature, which we announced this week. The ability to manage these things, everything that you do with Kubernetes today applies to Cloud Run on GKE because it's running on top of your existing infrastructure. It also means you can take advantage of the features of Kubernetes on GKE, like custom nodes, being able to bring in custom machine sizes, being able to access hardware accelerators like GPUs and TPUs, all of the advanced compute features that are available in the Kubernetes platform that aren't necessarily available on a serverless platform. are yours on Cloud Run on GKE. So we now have the ability to offer serverless anywhere. Between a fully serverless platform that's managed through Cloud Run, where everything is hidden from you and you don't have to worry about the details, to Cloud Run on GKE, where we manage the control plane and provide the same developer experience, but it runs inside Kubernetes engine, and Knative, which is the open source platform that makes all of this possible, which allows you to run the same API, the same control plane on any Kubernetes installation anywhere. So you can have the same serverless experience across the board, from fully managed all the way to do-it-yourself with open source. So let's step back and take a look at this picture again. With Cloud Run on top of GKE, now developers really can just focus on writing their code. They can have that serverless developer experience and still run it on top of all of your Kubernetes infrastructure. And they don't need to worry about all of those other concerns, so they can be more productive and get more done. Let's go a little bit deeper, though, because this is a 200-level talk, and talk about what are the actual benefits that you get out of using Cloud Run on GKE. So when I deploy my container on Cloud Run on GKE using the serverless infrastructure on Kubernetes engine, I get my container automatically scaled, including scaling to 0. So we look at the HTTP traffic that is coming into this service, and if there isn't any after a period of time, the container will time out, will spin down the pod, and it's taking up no resources inside your cluster. When a request comes in, it lands on an activator component, which understands which service definitions we need to go spin up. We'll create a pod or multiple pods, depending on how much traffic is coming in, and start routing the connections directly to those instances. And we'll scale up from 1, obviously, to as many as it takes to serve the load that you have. And there are some parameters that you can use to fine-tune how that scaling works. We also offer managed configurations and revisions. So we keep track of every revision of a service that is deployed through Cloud Run on GKE. And you can easily move between them. You can roll back to an older version. Say you deploy something new and there's an error, you can quickly revert back. We also ensure that while we're moving over to the new revision, there's no downtime. Requests that are coming in seamlessly get migrated from one instance and one version to the next one, so that your service can remain live in production as you deploy a new version. We also integrate with the Istio service mesh because we're running on Kubernetes. So every service that's deployed through Cloud Run on GKE is a member of the service mesh. And you can choose to expose that service either externally outside the cluster or only on the service mesh if you want to do an internal service. And Mark's going to do a really cool demo about that in a little bit. And then another great benefit of Cloud Run on GKE is that it enables a custom domain story and certificate management story on top of the cluster for serverless services. So we automatically generate URLs for those services that can be on a custom domain name so that you don't have to worry about all of the plumbing to make that happen. And then, of course, Cloud Run on GKE is built on top of GKE. So it can connect into a bunch of great GCP services, like Cloud Build and Stackdriver for doing logging and monitoring. But it's also a pluggable infrastructure. So if you want to extend it with a partner integration like Datadog, you can do that if that's what your business depends on. Or you can use GitLab as the CI/CD system, and we'll show you a little bit more about how that works here in a little bit. So let me give you a demo of what this actually looks like, just to get a little bit more real than me talking. So if we could switch to demo 1. Aha. Here I am in Cloud Console. This probably looks very familiar to everybody here. And I'm going to go into Kubernetes Engine just to show you what it looks like to stand this up. So I will create a cluster. I'll wait for my UI to load. And I'm going to go ahead and create a highly available cluster, because that's what you should be using if you have production workloads. And I'm going to scroll down to the bottom, and I'm going to turn on Stackdriver logging and monitoring. I'm going to turn on Istio, and I'm going to turn on Cloud Run on GKE. And I'm not actually going to click create because it takes a little bit too long for a demo, but that's how easy it is to stand up a cluster that Cloud Run on GKE can run on. Today, you can only do that when you create a cluster, but very soon we'll give you the option of doing that on an existing cluster as well. And once I have it running, I can move over to the Cloud Run UI now. And this is really the developer experience for deploying applications into this environment. If you think of the Kubernetes engine control plane as being the operator experience on Kubernetes, Cloud Run gives you the developer experience on top of Cloud Run on GKE. And I can just click to create a service. I can browse to find a container image in this case. I'll pick this one. Seems like the right SHA to me. And I will choose to put this into my Kubernetes engine cluster instead of into the managed namespace. And I'll just use default. I'll say that I want it to be exposed externally so that I can actually show you what service I have deployed. And I'll click create. And what this is doing right now is using the Knative API to go out and define a Knative service on this cluster. And under the covers, Knative is doing all of the work necessary to create the activator, manage the routing, program Istio to enable the URL that I have here to work, and making the whole system up and running. And now you can see my revision is deployed and ready for me to activate. And I'll click on that, and you can see here's my PDF service. If you came to the developer keynote last night, you'll be like, hey, I saw this before. But this is just a microservice that allows you to convert a Word document into a PDF. Very simple. You can see that it's running on Cloud Run on GKE. I can actually go back and deploy the same service onto the hosted Cloud Run experience, the managed Cloud Run. And you'll see it's exactly the same experience as I had before, but this time I'm going to pick one of these Cloud Run regions. And this is deploying it into the fully, make sure I check this box. This is deploying it into the fully managed serverless experience, where there is no GKE cluster. There's nothing actually backing this. And you see the developer experience is the same. So all of that is really cool, but what about Knative? What about being able to run this service in other places as well? So I'm going to show the last step of this demo, which is actually using the Knative API, the underlying open source, on an IBM cloud cluster as just an example. It could have been any Kubernetes cluster anywhere, but I happen to have one of those easily available. So I'm going to use gcloud run to get my service YAML, PDF service. And you'll see here's the Knative API YAML for my service. If I scroll up, you'll see there's a bunch of metadata, of course, but the spec is pretty simple. It's just saying to run the latest version of this revision and for this particular image. This is the Knative API very simply. And I will, I've actually put this into service.yaml just to show that I'm not lying. And I will do kubectl apply into my other cluster, the service.yaml. And this is going to do the same thing that the UI was doing before, create this Knative service on this Kubernetes cluster. And I can do get kservice, and you'll see that service is now up and running. I have this URL that I can access that is from this other service. And there, thanks to the power of Knative, I have the same thing running. So we have the same portability of the experience that normal Kubernetes would give you, but I didn't have to worry about any of the details of how to program Kubernetes, how to make it auto-scale, how to do all of those developer complexity things that I didn't want to do before. Knative, Cloud Run, and Cloud Run on GKE have taken care of that. So as a developer, I can just focus on writing my code and not be concerned with all of the other details of what I have to worry about. If we could switch back to the slides, please. So to give you a little bit more example of how all of this works in action, you need to give your thing to him. I'd like to bring up Daniel Gruesso from GitLab to show you how GitLab has integrated with Cloud Run on GKE and Knative to provide a portable experience for CI/CD.
Hello, hello. Hi. Thank you, Ryan. So at GitLab, we couldn't agree more. Kubernetes is the de facto platform for running containers. And we've worked to integrate a lot of those workflows in our product. All right. So serverless is no different. We believe Knative is an important part of enabling the developer experience and basically really allowing developers to focus on writing code and applications and adding value and not having to focus on maintaining infrastructure and configuring it and all of those things. So as you know, GitLab provides a unified experience for operators and developers where you can manage both your code and your infrastructure from a single app. So there's a lot of power in that. So let's see what that's all about. Can we switch to demo 2? All right. So here I have my GitLab project. Let's head over to operations and Kubernetes. So I see here that the operator has set up a Kubernetes cluster on my project, and Cloud Run on GKE has been enabled here. I see that the domain that I requested for my app has been configured, in this case, gitlab cloud.run. So here's where the benefits of GitLab start to become visible. Here I see that with a single click, an operator can configure that domain to the Istio ingress endpoint. And behind the scenes, what that's doing is that it's adding the domain to a config map to resolve all the requests to this service using this domain. So I didn't have to expose any configuration on Kubernetes, anything. It's a single click op. So that's really great. Let's move on to the project here, and let's take a look. And let's take a look at how easy it is to deploy a service on Cloud Run on GKE. So there are two types of services that I could deploy. I could deploy a function as a service, or I could deploy a full serverless app. And Knative will scale it up and down based on the requests. So for this demo, I will go ahead and deploy a function. So I only need two templates. The first one is the GitLab CI.yaml. And basically, this contains a reference to the Cloud Run CLI that we're using that will take care of building and deploying your Cloud Run service. And then the second template is the serverless.yaml. So I only need this one if I'm going to deal with functions. And here, basically, it provides information about my function, such as the name, description, the runtime that I'm using. In this case, it's going to be a trigger mesh Node.js runtime. And that's it. So that's really all I need to get started. So the very next thing that I'm going to do is I'm going to add the files that are specific to my function. So here, I'm just going to add 3 files. The first file is echo.js. This is a simple function that will echo back whatever input I give to it. And the other 2 files are package JSON files that hold the metadata for my service. So that's it. Let's go ahead and add those to the project. Let's give this a commit message here, add echo function files, and push. All right, so let's make sure that all those files made it back to my repo properly. Great, I see that the echo directory made it here, and it contains all of the files that I just pushed. So this, in turn, will create a CI pipeline that will actually take care of building and deploying the Knative service. So it takes about a minute to complete. So let me show you what it looks like when it's done. Here, I can see the whole process in a single stage of building and deploying the Cloud Run on GKE service. So when this happens, this will populate an entry in my serverless page. So that's under operations and serverless. And the entry on this page is going to be a reference to the Knative service. So here we'll see, as soon as it loads, we'll see a couple of things that are specific to the service. All right, so I see here the service name, the service description, and the endpoint where the service is being served. And that's it. So that means that my service is now out there, and I should be able to send the request to it. And hopefully, it will work, and it will echo back whatever input I give to it. So for this first test, let's give it this input, hello from Google Next 2019. Here, I'm just going to use curl. So you see the content type, the request type, and the endpoint. So let's go ahead and do that. So here the service is scaling from 0, so it's going to spawn up whatever resources it needs, and I see that it echoed back this data. So let's try it a second time here. This time I'll pass it GitLab serverless functions on Cloud Run for GKE. So you see that that second time it was a lot faster because the resources have already been spun up. And then basically as you give it load, it will scale up, and when there's no load, it will scale back down to 0. So here, if we click on my service, I'll see more detail. I see, because this is running on Cloud Run for GKE, there's a Kubernetes cluster, and I will see the scale for my function. So in this case, I see that it's using only 1 pod. As you give it more traffic, you'll see more pods spawn up here, and very soon we'll add the number of invocations that you have for your functions. So as you can see, it was very simple to deploy a service from 0. And while it's still early, you can see that there's a lot of power in that. And like Ryan said, we don't have to concern ourselves with being experts in Kubernetes. And this is being added to GitLab CE, which is open source. So you can feel free to contribute any use cases that you may need on top of it. And that's all I have. Back to you, Mark.
Let me switch back to slides. Daniel walked us through some of the benefits and the overview of the demo and kind of give us a good idea of how we can partner using the Knative APIs that are very open with broader number of partners in the community that enable whether it's CI/CD, whether it's logging, whether all the extra capabilities that you might potentially depend on when you were developing on-premise and how you want to use them in a kind of more distributed environment, whether it's in a cloud or continue developing on-premise, but using some of the technologies that Cloud Run or specifically Knative enable. So what I'm going to do now, I'm going to go in and maybe kind of highlight another use case that captures some of the more kind of real life scenarios as when you're developing a more microservice-based kind of solution. So what we're going to do is we're going to start with a very simplistic use case which is a single service deployed on Cloud Run that exposes a REST interface to the outside world that can be invoked with an image that then it's turning around and calling a Google Cloud Vision API to get an identification of a logo that might be included in the image. What we're going to do then, we're going to say, okay, that's great, except now everybody in the world is able to run my credits against Vision API, which is something I probably don't want to enable too much. So we're going to front this with yet another microservice, which is going to provide authentication using OAuth against Google OAuth service and expose simple UI also so that users can interact with that API much easier. That's great, except if you're paying attention right now, you're quickly realizing that both of those services are exposed to the outside world. So you probably say, I can just go around there, I can continue calling my original service and everything will be great. So let's see how Cloud Run, services on Cloud Run can help you to deal with this kind of situations. Can you switch to demo 1? All right, so I have a simple image here. You and I know what it is. I've seen a lot of hands raised initially when we kicked off the session talking about people who know what Kubernetes is. So you probably know what it is. But when a machine asks and looks at that image, you might know what it is. So the Vision API provides one of its sub-services that allow you to identify logos. So we're going to use this, actually, before we even go there, let's first of all deploy this image. I wouldn't want to run a REST service against something that doesn't exist. So first of all, we're going to run, it looks a little complex because we're kind of including some of the additional services. So Ryan has deployed service using UI. I'm going to show you how to do this using gcloud. Exactly same experience, the same variables, but just different tool. Obviously, gcloud is the tool. We're going to use Run, which is the service we announcing here. We're going to deploy. Here's my creative service that apparently always have to start with K now. And we're going to add a couple additional variables. We're going to deploy an image. You've seen during the demos as often for ease of demonstration, kind of deploy an image with latest, which is great for demonstration. Probably not want to do that in real life. You want to have a specific hash, SHA of the image that represents a state of that image that as it was, that it will allow you to benefit from the auto scaling without the worrying about that when you deploy the service today and the image and the solution has to scale to additional nodes tomorrow, that you're pulling a different version of the image. So that's a consistent same version of the image is going to be on every single service. And we're also providing a couple additional environment variables in here like release mode. So let's do this. Now, the thing I like to point out here during the demos is this is pretty fast. When you think about, Docker images can get pretty large. How fast you do this and how quickly you can deploy is pretty impressive. So what Cloud Run gave us here is a specific version. So the name of the service plus some unique characters there, and also give us URL. I have this entire cluster configured with custom domain and SSL certificates, so we can actually kind of resemble real world scenario. So let's go back to our curl and let's run it. So the simple thing, we're going to run a JSON. We're going to post a JSON object, which is very simple, has only an ID and a URL, and then we're going to pipe it through jQuery so we can have a little more color over response. So we see here very quickly the service was running. It returned a identification. It identified that as Kubernetes. I'm actually underselling the Vision API. Vision API returns a broad number of set of features and capabilities, features of that image, including attributes, colors, and all other things. I'm just extracting one thing for ease of demo, but Cloud Vision API is pretty impressive service. Okay, so what we're going to do now is there's REST interface, so it's great, but let's deploy that. Where are we? Let's deploy the UI application so we can actually take a look at it. Again, much bigger command. Yes, there's more environment variables in here, but bottom line is we're going to run the exact same thing. And when that is done, great, we can actually switch to the browser and start using. Can you guys see it? Yeah. So clearly an application created for demonstration purposes. There's no much there. But one thing that we can do is we can easily log in here into a service. I'm going to use my personal one, so I'm not exposing any Google stuff here. And we have a nice UI. Oh, I have to go shopping. I think it's the same T-shirt I was wearing when I was taking the picture. All right, so back to our Kubernetes image. We can run this through the same UI. But like we said, there is this problem that I can continue coming back to my curl and just running it. So clearly not working as intended. I'm going to come back to this UI in here. We have this new version. Let's refresh this because we just deployed a new version. So now you see the 2 minutes ago I deployed a new one. There's a number of features here, logging, details. You see the environment variables. You can actually see the YAML file that Ryan has deployed across IBM Cloud and ours. You can consume the same thing with environment variables. The one thing I want to highlight here that in addition to these other capabilities, you can actually come in here and very easily change this to an internal service. So let's see. Let's wait for this to finish. Let's come over here. And first of all, clear this and maybe do a little verbose. All right, so curl is a lot more verbose, but the important thing is over here. First of all, the service was 404. So not only we've introduced, it's not like we put some kind of token or security on it. We literally removed the route to it. It's not accessible from outside world. The other thing you should notice here, that automatically we recognize that this traffic supports HTTP too. So we've upgraded that service to HTTP. Too. So let's now see if our UI continues working, because if we just shut down the backend service, that's probably not what we wanted, right? I don't think we used YouTube before yet. There it is. So our service is able to use this service, the backend service internally inside of the cluster by discovering its internal URL and consuming that versus using the external. That's a great capability that allows you to start mix and match different services. And you continue benefiting from the Istio mesh that's running underneath to give you the telemetry, access policy, request paths, and all that. In fact, Istio request path pattern is actually, request path access pattern is actually used in here to deliver that very capability. All right, so let's switch to slides. So what we've done here, just to recap, we've deployed a number of services. Actually, going a little further, what I've done, I deployed yet another service that's providing a metering. So we actually keep a state of each user's requests, and we persist them into Firestore API. So even if you were to go to the UI and start using it, 1,000 of times, I will shut you down after 100 of queries per day. So we have a number of backend services that are accessible only internally. They're accessible to the front UI as a backing service, but the front UI is the only service that's exposed externally and allows users and forces them to authenticate. Little more real-world scenario of how you would develop those applications. And the beauty of this is that you can keep building on that. You can continue adding using Cloud Run. You can keep on GKE. You can continue building those services. And behind the scene, if the UI is not exposing something, you can use kubectl to manage this as if this was normal Kubernetes service that was deployed by you. All right. So, Ryan, tell us again about what the different options we have and where we can run these services on using Knative backend services.
So, thank you, Mark. That was, I think, a cool demo. Did everybody else think that was a cool demo? No, I'll beg for applause. That's fine. It's a product manager job. So serverless where you want it with Knative and Cloud Run. I want to emphasize the portability aspect here, because really what we're trying to do is make it so that you can have the developer experience of serverless in any environment where you want to enable that experience. We know that not everybody fits into the mold of what a fully hosted serverless option can offer, and that there are lots of reasons why customers want to stay on GKE, on Kubernetes, and run on Kubernetes really anywhere. But the developer experience shouldn't have to change as a result of that. You should be able to get the same experience for how you write code, being idiomatic, as Mark said, my favorite word, across all the different ecosystems, so that not just the workload can be portable, like I showed, being able to deploy the same thing in multiple places, but that the skills can transfer, that the developer experience can be portable, so that what I learned today using Cloud Run on GKE can, on my next project, be applied to Cloud Run, and on the next project be applied to an on-premises cluster. And so, we've announced these products, Cloud Run on GKE, which are in beta today. I really encourage everybody to go out and try these out today and give them a try. And look at Knative as well, if you have a Knative Kubernetes cluster, where you're interested in running serverless workloads. I talked about this already. So there's a bunch of related sessions. Of course, this is afternoon on Thursday, so almost all of these have already happened. They're all going to be on YouTube in a matter of a few days. So please go back and watch them if you're interested more in about Knative or in the overall Cloud Run vision. I do want to plug, though, that SVR 305 is happening this afternoon, which is a deep dive on Knative eventing. So everything that we talked about today is on the serving path and being able to auto-scale your workloads. But if you're familiar with how we define serverless, and one of the slides that Mark talked about, there's that event-driven piece, which we sort of didn't talk about a whole lot today because it's still coming through Knative eventing. And so Ville and Mark are going to be presenting both the vision of where eventing is going, as well as some really cool demos showing how eventing can be used today. So definitely check that out.
And maybe one thing to add in here is that clearly this is beta product. Cloud Run is still in beta right now, and Knative itself is 0.5 release. A lot of the use cases that you're trying to address, specifically on-premise, are something that we would be very interested to understand better and see how Knative solves for those. So if you are at all dealing with Kubernetes and serverless seems like something that Knative and Cloud Run can help you with, please use some of those URLs in here, including there are some feedbacks on Twitter, as well as Knative Dev has some additional links you can use to kind of give us some ideas of what's missing or what else can we add to Cloud Run itself to make this more kind of appropriate for some of the use cases you're trying to solve with.